Hi, I am Carmen. I am Carmen Popoviciu on Twitter. If you want to follow me or, I don't know, see what I'm writing every once in a while. There are two things you need to know about me. The first one is that I really, really love trampolines. So whenever I can get the chance to go and jump up and down, then I'll do that. And then the second one is that I'm a very happy person when I'm around cakes, like of any shape and size and of any flavor. I become really, really, really happy around them. Another thing is that I also love very much ASCII smileys. That's why also I themed the talk around smileys, because I think they just make the world a better place. This is my favorite ASCII smiley. And this is the improved version of my favorite ASCII smiley. And in case you missed it, it was just the smile was animated a little bit. And we're going to learn how we're going to do that. So a few words about this talk before we start. I presented it the first time at Vox Zurich. And while I was working on it, there was this person on Twitter who asked me what Polysmileys are. Because there seemed to be some sort of confusion. It's not an official thing, it's just my thing. It's basically Polymer combined with smileys. And I used it because I think it's just a nice and a fun way to learn about Polymer and about web components. So that's just it, in case you were wondering. As I told you, I chose this theme because I really think that smileys make a world a better and friendlier place. I want to give a shout out to these two guys. All the slides that you're seeing and all the code snippets that you'll see are basically Polymer elements, custom elements. And I'm using these two elements. You can find them on GitHub. Both tags are linked to their repos. So a big shout out for them because, well, they were also kind of the only ones that were using the latest Polymer version. So I was like, yay, cool. So yeah. And the last warning is that the talk is going to contain an overdose of smileys. So you're going to see like really a lot of them and a lot of them. Yeah. So let's get started. I divided this talk into two parts. One is about web components, and the other one is going to be about Polymer. I want to do a raise of hands. Hands up, who knows about web components? Okay, who's working with web components in production? Okay, that's kind of what I thought. Who's working with Polymer in production? Okay, still nobody. Okay. Right. I wanted to start with web components because I think that in order to use Polymer, I think it's very important to understand what web components are so that you can get the full power of what Polymer can do for you. And I also want to give a bit of a comparison between how you would create custom elements with pure web components and how you create them using Polymer. So just that you have an idea and the pros and cons of each of them. So web components. Web components is basically a W3C standard. It's basically an umbrella term for 4 standards. Web components allow you to create widgets and components in your web applications. The 4 standards that I mentioned are custom elements, there are HTML templates, there's the shadow DOM, like the very scary shadow DOM, and then HTML imports, which has a bit of a discussion around it. So let's go through each one of them. And the first one is going to be custom elements, because those are the coolest ones. Custom elements basically allow you to extend the HTML vocabulary, and they will allow you to define your own custom element. So it's like you're creating your own button, but it's like this special button, and this button is going to do what you want it to do, and it's not like the user agent button. So we could have something like this. This would be a custom element. This is a custom tag. This is something that you would create. It does exist because I made it. And it does pretty much that. It's just an animated small ASCII smiley. Custom elements will give you a few benefits that you need to be aware of. First of all, they will give you a declarative way of creating components. And this is very important because you're going to avoid the div soup that we all like very much. So instead of having an HTML markup that is going to look like something that nobody can read, you're actually going to have some meaningful tag elements there that will give meaning to the users or developers that are reading your markup. So yeah, it also gives you this readable markup, which is great because then people will not be confused, and then you don't have to get lost in all these divs and all these spans and anything. You will just see what the element is there, and it will have meaning to it, so you will know what that element does. It also provides you a way to create reusable components. This means that once you write a custom element, you write it once and then you can use it anywhere you want. It doesn't matter, as long as the application supports web components. It's also self-sustainable, so that means that if you're consuming custom elements that you wrote or other developers wrote, it kind of means that you don't have to worry about the internals of that component. It's really the job of the creator of the component to be worried about that. And custom elements give you all this, and I think it's really great. There are a few things we need to know about how we can create custom elements. There are two types of custom elements, actually. The first one is they're the autonomous custom elements. And in order to register them, that basically means that you're going to add the element definition to a registry. It's kind of like this. The document has a registry attached to it, so then when the parser parses your document, it's going to look in that registry, and it's going to check if it knows of the existence of that element or about the definition of that element. And that's basically what you're going to do. When you're going to create your own custom element, you're going to give it a name, like the ASCII smile, and then that name is going to go in that registry. So whenever the parser is going through the document, it's going to find the ASCII smile, and then it's going to say, oh, I know, I can take that up from the registry, and then it's going to know what it has to do with it. This is going to look something like this. So you have a register element API on the document, and then you can call it with the type of your custom element, which is ASCII smile. That's basically your tag name. And then the second parameter is going to be the prototype of your custom element. So that basically means what your custom element inherits, like who it's going to inherit from. By default, in most of the cases, you're going to want to inherit from the HTML element because, yeah, you're creating HTML elements. But per definition, you can inherit from other elements as well. And this API call is going to return a constructor function. So you can also imperatively then call this constructor function in your JavaScript code and then create instances of these elements. If you're going to use it in your markup, it's going to look simply like that, which I think is very nice because it's just it's very clear and to the point. Then the second type of custom elements are customized built-in elements. And these are basically elements that are going to exist. They're going to extend existing elements. So for instance, in the example of the button that I gave before, you might not want to create a whole new button from the startup, but you can inherit from the native button and then just add some extra functionality to it. And that's going to look something like this. So you see we're registering an element, which is the ASCII Carmen smile. And then you'll see that the prototype is, again, so it's inheriting from the HTML element, but it's extending the ASCII smile. So that means that when you're going to invoke it, like use it in your markup, it's going to look something like this. So you're not creating a new tag. It's more like an attribute element, per se. There are 4 lifecycle callbacks that you can hook into when you're creating a custom element. There's the created, attached, detached, and attribute changed callback. These are basically points in the creation of a custom element that are very important. And having these hooks will allow you to perform certain operation based on the life cycle of the element. So for instance, when you're creating the element and then you want to perform something like, I don't know, add a certain text inside of the tags or, I don't know, whatever you want, then these life cycle callbacks are the places where you are going to do that. Also, the attribute change callback, that's another important one. So if for instance, you're passing, if your custom element accepts attributes to it, when those attributes change, you might want to perform certain internal operations for your custom element, and then the attribute change callback is the callback that you want to be, or it's the hook that you want to be using. Then there are templates. Oh, by the way, if you have questions, raise your, yes, cool. That's a good question. I am not entirely sure. I know that per definition, you can inherit from HTML elements and SVG elements. I'm not entirely sure about if the MIME type is XML. Yeah. But that's a good question, and I can look it up. So just come after, and then we can look it up. Cool, thanks for asking. Any other questions? Okay. Templates. Templates are very cool, because what templates basically allow you to do is have markup inside of your markup that is parsed, but it's not rendered. So it's basically just an inert piece of HTML inside of your document that you yourself have the power of instantiating when you want. That means that, for instance, if you have some markup with some scripts inside of it or some images inside of it, none of the scripts will load, none of the images will load, there will be no HTTP requests sent, so nothing will happen. It's like just a piece of inert code there that is just going to wait for you to attach it to the main document. And the reason for this is, like, if you want to know the internals, it's because templates are associated with a document fragment that is not associated to the main document. So that allows it to just be inert, and it allows it to just not send any XHR request or load any images or things like that. The things you need to remember about templates is that it is going to be parsed as HTML, but it's not going to be rendered. And in order to use it, you will need to clone it, and you can instantiate it at runtime whenever you want in the lifecycle of your application. So how does that look like? There is a tag for it, the template tag, and inside the tag you can declare pretty much whatever you want, like any HTML valid markup that you would use in your HTML documents that's very valid inside the template tag. So you can pretty much use whatever you want there. And then when you want to use it, you see that we're querying it by its ID, and then we're going to import it. That's going to clone that piece of markup, and then we're going to append it to our host, which is rendered in the main HTML document. Does this make sense? Sure.
One question. When you view the source code, do you see the template or?
Yes. Shadow DOM. I think one of the features that people love most about Shadow DOM is the fact that you can encapsulate CSS with it. And like that's really the thing that got everybody go like, wow, okay, we like that. I like to think of it as a soap bubble around an element, and everything that's inside the soap bubble, it can exist by itself. It's not touched by anything outside. It's really everything that happens inside the soap bubble stays in the soap bubble. So it's like everything that happens in Vegas stays in Vegas. It's a bit like that. So there are a few concepts that you need to know about Shadow DOM. It's also the scariest one of the standards, but, well, it's not so scary if you understand it. The first one is the document tree. And that's the node tree whose root node is a document, so it's your document, basically. Then you have the shadow host. That's going to be the element to which you attach a shadow tree. Then there's going to be a shadow tree, which is a tree that is hosted by a shadow host. And then there's the shadow root, which is the root node of the shadow tree. And I'm sure this is like super clear for you. That's why I think this image kind of helps in understanding it. So the tree that you see on the left-hand side, the green one, that's your document tree. That's what's rendered in your HTML. And then the thing on the right, that's going to be your shadow tree. So at the moment that you take a shadow tree and you're going to attach it to a shadow host, what you'll get rendered will be this. So you can notice that we still have the shadow host, which is the node element that we attach the shadow tree to, but then all the children of the shadow host kind of disappeared. And all that is replaced by the body of the shadow tree. And I think this is still kind of confusing, so that's why I want to show you something very cool and awesome. It's something that Eric Beidelman built. It's a very cool Shadow DOM visualizer. And it basically, let's see, can you see it now? Okay, cool. So it basically shows you how the shadow tree is going to be rendered. This is going to be the host node, and this is everything that's inside the Shadow DOM. Maybe I should make it easier, but I don't want to do that. But it's, I think it makes it pretty clear. You can see which nodes are part of the shadow tree and which are the children of the host node. So everything in yellow is part of the Shadow DOM, and then everything in blue is part of the original tree. And then you can see, because I mentioned that the children of the original tree were replaced by everything that was in the shadow tree, you can see that we have these content elements here. They're called insertion points, and these are points where you can declare, okay, you can have a selector and select nodes from the children of the host node, and then you can just render them in the places that you want. Does this make sense, more or less? Oh, that's not a yes or a no.
What is it good for?
It's good for exactly the thing that I told you. So if you can imagine you're building a custom element, right? And the internals in the internals of that custom element, for instance, you declare some ID tags, you have some styles attached to it, and then the styles you use some class selectors and so on and so forth. Now imagine you're using another custom element that somebody else built, and they're using the same IDs and classes as you are. If you wouldn't have style encapsulation, it's going to be a mess, because your styles are going to be affected by the styles of the other custom element. But because when you're creating a custom element, you're using Shadow DOM, all your styles, or all your IDs, all your HTML is encapsulated in that. So nothing is going to bleed out and nothing is going to bleed in unless you particularly declare that. So you can do that, but you have to do it yourself, like imperatively. It's not like if you have two custom elements that kind of work on the principle of the same IDs and same classes, they're not going to affect each other. So this kind of gives you the assurance that whenever you have a custom element, it's going to behave like you want it to behave. It's not going to be affected by anything else you might be using in your application, like third-party libraries or things like that. I think that's the biggest benefit of Shadow DOM. Does that make sense? Cool. Oh, wait. Back to the slides. Okay, and then there's HTML imports. And then HTML imports basically allow you to include HTML in a declarative way. So for instance, like you have script tags for scripts or image tags for images, then you have this super nice tag, new tag now that allows you to include HTML documents. That will look kind of like this. So you see that link tag at the bottom. There's a special rel attribute with the value of import. And then what you need to do is you just need to specify the path of the HTML document that you want to include, and that's it. There is a trick though. When you're with HTML imports, it's important to remember that when you're including an import on your page, you're including the document. So if you want to start accessing the contents of that document, you need to use link.import. Does that make sense? And then you would just use it like this. So you would query the link tag, and then you would just access the import, which will return the content of that document. I'm going to give you an example, and then maybe, yes, cool.
So how do you decide whether to use templates or HTML imports, and what are the advantages?
It's a good question. I think, well, I don't think. So HTML imports and templates are basically two different things. HTML imports would allow you to import a document that has a template tag inside of it. And what I mean by that is that the document that you're importing, it can really contain anything you want. I mean, of course, the template tag as well, but it's different because the purpose of the template tag is really to have. It's really like a template. It has this markup that you just need to stamp out and use it inside of your application. Whereas with HTML imports, you can pretty much include a whole application in itself. Does that kind of explain it to you?
Yeah. So can you, for example, import with HTML import from another domain?
That is a good question. As far as I know, yes. But I would need to double check that. But yeah, as far as I know, yeah. Right, so I just want to give you a very quick example of how the ASCII heart custom element would be implemented like. So you see we have the template there, and we have the script, which clones the template. What else does it do? It clones the template, and then it creates a shadow root, and then the contents of the template is added to this shadow root. And then it is, the clone of the template is attached to the shadow root. And that's pretty much it. And I mean, the result would look something like this. I didn't add the styles to it because I don't think they're relevant. But this is pretty much everything that we covered so far. So we are creating a custom element based on a template that is predefined, and we are encapsulating everything around that custom element by attaching it to a shadow root. Does that make sense? Okay, and now you're gonna hate me. So I thought a lot about whether I should show you this or not. So currently the specs, yeah, do you know?
I can imagine.
He can imagine. So I think one of the reasons why people are afraid to use web components is because the standards have been very flaky, so they have been very unstable. There has been a lot of discussions around it. It's been hard for the community to get consensus around it, so for all the browser vendors. So currently, everything that I have showed you is based on the specifications in version 0. It's I call it version 0, but actually they say that it's not a version per se, it's more like a priority. But I mean, the specs have really changed. In version 1 of the specification, most of the APIs will change. The concepts will stay the same, so that's why I still wanted to go through them. The concepts will stay the same, they will really stay the same, but the APIs will change. Like registering custom elements is gonna be different, there's a different registry involved and things like that. But they're getting there. So there's a lot of consensus. Chrome is working on it, Safari is working on it as well. For Microsoft Edge, they're also interested in working on it. Templates are already part of the specification, so the most discussions are around Shadow DOM. HTML imports have kind of been dropped off because the committee is waiting to see what's going to happen with ES6 imports. But yeah, so that's kind of the status. I could show you a can I use screenshot of of what the current status is, but I think that really at this point, I have something to fix it for you. So I've been gathering a set of resources, and if you access it, you're gonna see links to the bug tracking system for every major browser vendor, and there you can see like what the status of the implementation is, and then you can also see links to the working drafts. And well, I think that will give you a better idea of where you are. But just keep in mind, HTML templates are there, so they are part of the spec. Polymer. Oh, and I only have 23 minutes. Polymer is basically a library that is built on top of web component standards. And the cool thing about Polymer is that you won't have to worry about things like who supports what. And that's because they're using webcomponents.js. He's nodding, he knows. So webcomponents.js is a very cool polyfill. They're really up to date. Like last night I was checking whether they're supporting the new APIs in version 1, and they're actually kind of getting there, which is really cool. So there's a lot of speed to that project, and that's great. And so Polymer, by using that, of course, you can also use that yourself when you're writing vanilla web components, but by doing that, Polymer already fixes that for you. And also, Polymer adds a lot of syntactic sugar as to how you can write custom elements, which I think is really great. And I have a very nice slide at the end where you can see the difference between writing vanilla web custom elements and Polymer custom elements. The stack is pretty much this. So you have at the bottom, you have the web components primitives, and that's because Polymer is based on the web component standards. Then on top of that, you have the Polymer library. And then with Polymer, they have a lot of pre-made custom elements. They pretty much say that there's a custom element for everything, or they just say that there's an element for that. Before writing anything, I totally recommend you to check their elements. They're really good, and they really cover a lot of scenarios. And you can find that on their project page. It's a very cool stack. Some of the features that they're adding to vanilla web components is easier element registration, local DOM, declared properties. They bring data binding into the picture, which is pretty interesting, I think, and they also make styling of custom elements easier. For element registration, Polymer provides this Polymer function, which just requires the prototype of the new element, and it looks something like this. So if you invoke it, the type of the element is always going to be mandatory. That's pretty much the same as the name when we were declaring vanilla web components. And then you have a lot of other stuff like properties and all the callback functions. And then if you want to use it, in principle, it's pretty much the same. It will return a constructor function, so then you can either create elements imperatively by calling that constructor function, or you can use document.create element, or you can just use it like this. So it's kind of pretty much the same as I showed you before with web components. There is one difference though. Polymer will take care of the prototype chaining for you. That means that all the custom elements that you're going to create with Polymer, they're going to inherit from the Polymer base, which basically means that you're always inherit from an HTML element. And well, I had to look that up because I was curious, and that's pretty much what the base will offer you. And you can also see all the custom elements callbacks that you can hook into. There's also another interesting thing you can do with Polymer. You can use a class style constructor, which means that you can create custom elements, but you don't have to register them immediately. This will look something like this. So you will have the class function, and then the prototype is pretty much the same as if you would use the Polymer function or the Polymer API. And then you can register the element and then create instances imperatively like this. But that's pretty much the only difference, that it's just not registered immediately. Yes?
You mentioned that all the classes elements created with Polymer are extended from the Polymer base class.
Yes.
And for the web components, I can pretty much extend the HTML element, but I can extend some other custom component.
Yes, that's a very good point. I think I'm quite sure I have it somewhere in my slides. Because your custom elements will always inherit from the base class, you'll always be kind of attached to the HTML element. So you can only extend native elements. You cannot extend other custom elements that you've created. There is kind of a workaround. I have not worked with it, but that involves behaviors. So I'm not sure per se how you do it, but I know that by just using the constructor functions, you cannot do it. And that's a very good question. I think it's actually here. So the type extension elements, it's pretty much like the customizable built-in elements that we talked with web components. So it's like that extra special button that you want to create. And it looks pretty much like this. So the prototype of the element you're creating or the prototype declaration is the same. The only difference is that you need to specify which element you're extending. And then the instantiation or registration of the elements is the same, and the way you use it in your markup is the same as you would with web components. And it's only for native elements. So that relates to your question. Does this make sense? Cool. Ask questions, please. You have the same lifecycle callbacks with the only difference that you have an extra one called ready. And this one is called when the property values are set and the local DOM is initialized. That's the only difference. The rest are all the same. And since we were speaking about local DOM, you can think of local DOM as the DOM that a custom element that you're creating is responsible of. And then when we're speaking, in the Polymer land, there are two ways that you can deal with it. You can either use Shadow DOM for the browsers that do support it, or you can use Shady DOM. You can use Shady DOM for the browsers that don't. I see people going like, oh no, oh no. So Shady DOM is pretty much, I think of it as a wrapper around Shadow DOM. So the APIs are the same as for the native one. The only difference is that Polymer does a bit of magic, and it knows how to handle certain events and so on and so forth. And it is turned on by default, so do remember that. You can change it. There's a setting configuration where you can specify, okay, I want to use Shadow DOM if that's supported, but by default, Polymer uses Shady DOM. If you want to create local DOM, there's an element for that. It's called a DOM module, and then inside of this DOM module, you can put your template. So that's going to be the template of your element, and we know what the template is because we talked about it. And then you can create your element, and that's pretty much it. The trick here is, though, notice that the DOM module has an ID. That needs to correspond with the type of the custom element that you're creating. So I'm not sure if I can do this, but that was the effect that I was looking for. So those two need to correspond. That's the only trick you need to remember. And then for the rest, I think it's pretty self-explanatory. The script tag doesn't necessarily have to be inside of the DOM module, but if you do want style encapsulation, the style tag does need to be inside of the DOM module tag. Does that make sense? Cool. Now, if you're creating local DOM, you're probably going to want to start accessing elements inside of the template of that element. It is important to know that Polymer keeps a map of all the static node instances, and you can access them by calling this $. And all the nodes that are dynamically created can be accessed by this $. And I'm going to explain what I mean by this. So notice that inside of the template we have this div with the ID heart. So if inside, if for instance when the custom element is ready, in the ready function callback, you would say, for instance, that you want to access that element. Because it's a static node, you can do that by calling this $. Does that make sense? It's like this is something that you created. Dynamically, I don't have an example for dynamically created elements, but Polymer has something like if and repeat. So if you want to create a list of I want to explain it using AngularJS terms. But if you would, for instance, if you have an array and you want to loop through that array and create a node for each one of them, that would be dynamically created, right? So then if you would want to access those nodes, then you would use the this $. Does it make sense? I'm not sure if I explained it right. Okay, I can show you an example if you come afterwards. It was too much for this presentation. Right, then you have insertion points. Remember that I showed you the thing with the shadow DOM and those content tags? Well, Polymer supports that. So you do have insertion points via the content tag. And this content tag has a select attribute which allows you to select the specific markup that you want to stamp out of the light DOM and insert it in your element. So this will mean something like this. If I have an ASCII shrug component, and then you see that those two spans inside of the component, that's something that we call light DOM. So those are light DOM children. And if, for instance, I want to take the text of one of those and replace the face of my ASCII shrug with one of those two, I can do that by adding the content tag over there, and I can select the one that I want using the select attribute. And you can see that I'm selecting by class, for instance, but I can also select by ID and so on and so forth. Does this make sense? Cool. Yes, the ASCII shrug again. Remember I told you that at its core, Shady DOM uses kind of the same API as the native DOM. It is very important to remember that when you're using Polymer with the Shady DOM, you are pretty much forced to use the DOM API that the Polymer provides. And this DOM API looks something like this. So it's pretty much I'm missing the word, but it's sorry. So it's pretty much the same as the native API. It's just that it's exposed through the Polymer API, and then you will definitely need to use that. So there's no working around it. Did I explain it right? I'm sorry, I missed a word. English sometimes. Declared properties. You can also create custom elements that have properties on them. You can think of those as the public API of your element. These are they will come in the shape of attributes when you declare your element. So let me see if I have an example. Yes, I do. So you see we have the ASCII hello, and then the face and the waving hand. Those will be the API that is exposed to the consumer of the component. And these are values that the consumer is going to pass in, and then the component is going to take them in and then act based on those. And these are the declared properties. And you can have this with vanilla web components as well, by the way. It's just a different way of declaring them. So if we declare a component, then there's this property in the prototype declaration. And then you see that we have, we're declaring the face property and the waving hand property. And the thing you need to remember about this is that when you're declaring a property of a custom element, you have a few options, like you can declare a type for it. You can declare a default value. You can declare whether it's read-only or not. That means that if somebody from outside wants to change it, they're not going to be able to do it. You can declare whether, if that property changes, do you want to tell the parent, or do you want to propagate that in your tree? So then you have the notify property, which allows you to do that. And then you have observers, which you can call in the moment that the property changes. Does this make sense? Data binding. I think data binding is a very interesting concept that Polymer brings in. It's not a new concept, but as opposed to web components that they just don't support this, Polymer really brings this in. And it's also very interesting to see how they do it. When you're talking about data binding in terms of Polymer components, you really need to think like a communication channel between the parent and the children nodes. It's really that. So it can be one way, it can be upward or downward. And I'm going to show you examples of that. But you always need to think in terms of who is the child and who is the parent and how do they communicate with each other. So data binding will look something like this. I don't want to stay on this slide for too long because I have some more in-depth example, but the double curly braces, that's the syntax for data binding. And that basically means that in my ASCII host, I have this disco color property, and then in my ASCII smiley, and in this case, the ASCII smiley is the child, and the ASCII host is the parent. So then I'm setting the color of the ASCII smiley based on a property that is defined on its parent, on its host. Is this clear? Because it's very important to think in terms of this. Because there are two data binding notations. One is the double square brackets, and one is the double curly braces, and they mean different things. So the double square brackets means that you only have one-way data binding, and the flow will be downward, so from the host to the child. And then the double curly braces can mean either one-way data binding or two-way data binding. And I think This is very confusing. Like, it really took me some time to figure it out. And that's why I said that, well, we have to dig in a little bit deeper. So what does it mean, one-way data binding downward? This means that, in this case, so for all the examples, the ASCII smiley is going to be the child node. So this means that if I'm using the double square brackets notation, that's always going to be one way. So that means that if disco color changes on the host element, that change is going to be transferred to the child. But if the color on the child, if the color property on the child will change, that will be not transferred, like it will not be emitted upwards to the host. So the flow is always from the host to the child. Clear? Cool. Then you can also have one-way data binding downward, like in a downward flow. Even if we're using the curly bracket notation, you will see that on the child, we're declaring this notify property that I mentioned earlier, and we're setting that to false. So that means that even if the notation allows for two-way data binding, because the child will not notify the host when its property is changing, the data binding will still be one way and the flow will still be downward from the host to the child, because the child will never notify its host when its property is changing. So that change will never be propagated upwards. Make sense? Cool. I have 3 minutes. Then there's one-way data binding upward. In this case, we're still using the curly bracket notation. But you see that we're also declaring on the child that it's the property is read-only. So that means that even if the host, the parent, wants to change that property, it will not be able to do it because that property is read-only. So that means that when that property, any change that happens to that property will only be propagated from the child to the host, and that's because we're allowing it using the curly brackets notation. The curly, yeah, you get what I mean. Makes sense? And then there's two-way data binding, where all of those extra properties are gone and everybody allows for the flow or for the change to travel from both ways, from the host to the child and child to the host. And you can bind to text context, which is basically something like this. Oh, styling in 2 minutes. So if you want to style your custom elements, I already showed you that you have the style tag and then you add all your styles there. If you want to style your host, there's this semicolon host notation, which accesses basically applies all those styles to your host element. There is one trick though, and this is the part where I actually want to get. If you want to have external styles that are applied to your custom element, that's not going to work the custom usual CSS way. You really need to declare a style element. And then you will do that by just declaring a regular Polymer element with a template and a style tag inside. And then when you're going to use that, you're going to import it, first of all. And then second of all, inside your template, when you're using that style component, you see that there is that extra is custom style declaration, and that pretty much tells it that, okay, I have this external style element, and I want to use the styling in there in my component. Sort of makes sense? Okay, the ASCII heart. This is what we had with vanilla web components. This is what we have using Polymer. So, this and this. It's just that Polymer abstracts a lot of the internals of web components away from us. There's a lot of extra stuff that it does, but, well, there's too little time apparently to go into that. And then this is something that I found when I was walking yesterday through the city. When I gave the talk in Zurich, I found a big smiley place on the way to the venue. So it's really cool to see that I always, like, a smiley pops up when I give this talk, which is cool. Thank you. I had candies for you because I wanted to take the last 15 minutes to like have a nice, cozy chat. I still have the candies for the people who asked questions. Come over and get your candies. And if you have other questions, just come and yeah, thank you.